Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 5, Section 4, Equilateral and Isosceles Triangles. Isosceles triangles are special, and they're Mr. Greenstein's favorite figure because they solve so many problems. An isosceles triangle is a triangle that has at least two equal length sides. So an equilateral triangle is a special case of an isosceles triangle. Let's look at the parts of the isosceles triangle. There's the vertex angle, and that's the angle that's between the two equal length sides. Then we have the base, which is the side that not necessarily has to be the same length as the other sides, so that's the base. We have the base angles, which are connected to the base. And then we have the legs, and the legs are the sides that are the same length. So these are the parts of an isosceles triangle. The base angles theorem states that if two sides of a triangle are congruent, which in this case makes it isosceles, then the angles opposite them are congruent. So then these angles are going to be congruent. The converse of the base angles theorem says that if we start out with angles that are congruent, then the sides also have to be congruent. So both of these theorems work, the base angles theorem and the converse of the base angles theorem. Sometimes it's called the isosceles triangle theorem. Complete the statement. If HG, that's this, and HK are congruent, then that means that this angle here must be congruent to this angle here. So we're going to get this angle is congruent to this angle. If H or KHJ is congruent to KJH, that means that these two angles are congruent. Then that means that we're going to have congruent sides. And the two congruent sides are going to be KI, or KJ, and KH. They're going to be congruent sides. The corollary to the base angles theorem says that if a triangle is equilateral, equilateral means equal sides, then it is equiangular. And the opposite can be true. If it's equiangular, then it is equilateral. So the converse to the base angles, corollary to the base angles theorem. Here are some problems that I'd like you to work out on your paper and figure out what x will be. Let's just work out the first one together. In this first problem, I have vertex angle of 30. The base is over here because I have my two legs here. So if this is 30, and then we know that both of these angles have to be the same value. So what we would have is 180 degrees is equal to 30 plus 2x, because we have another x over here. And then you work out what that value is. And then I'll let you work out the rest of the problems, and we'll discuss this in the next class.